All right, so let's start going over the definitions. So what is the definition of speed? Somebody.
The distance and the option over time.
Yeah, so it's the amount of distance over some sort of time. Okay. That always equaled speed. It's not necessarily how fast you're going, okay? Is that it better? Yeah. What about distance?
How far an option has traveled.
Okay, very good. How far an object travels. Now, remember, speed, we'll go back to speed really quick. Speed is measured in some sort of distance, so say meters, over some sort of time, so say hours. Or I should say miles per hour, right? So when we're looking at a math problem and we see both of those things, or we see miles per hour or kilometers per hour or meters per second, we know that that is a measure of speed. With distance, Jacob, I want you focusing up here, okay? With distance, we use like meters or kilometers, miles, right? Instantaneous speed. Allie, what do you have?
It's a speed at a specific point.
Speed at a specific point in time. Very good. Constant speed. Christian, what is that? Same speed for a period of time. Very good. And displacement. Jacob, what's displacement?
Well, I have it from the note.
That's fine. What is it?
The distance between the starting point, no matter the path.
Distance from the starting to end point, no matter the path. So it's like straight there. And then motion, don't worry about motion. I'm taking that off there. It's basically movement. Any questions on the definition so far? All right. Now, I saw a lot of you guys struggling yesterday with these. So, we're going to go over them together. Okay, how far did the player travel from a green dot to the yellow dot? Okay, first of all, when we're looking, this says how far. So we're looking for a distance. Now, this is a football field. So every big number is 10 yards, right? If we look here, that's 10 yards, that's 10 yards, that's 10 yards. But what if we go, say, from 50 to this one? How many yards is that? It's 5. Okay, because we're going halfway. So, with that in mind, let's mark up our thing. It says, how far did the player travel from the green dot to the yellow dot? Okay, I'm going to use little humps. Count with me. How many yards? 10, 20. I should hear everybody. You can count by tens. 30.
40.
So how many yards did we go from the green dot to the yellow dot? They're yards. Okay, now the question says from the yellow dot to the red dot. Again, how far? We're talking about the distance. Count with me. Wow, I'm glad a couple of you know. We'll do it again.
10.
Thank you.
20.
And we only go halfway, right? So what is that? 25. What? 10, 25. How far did the player travel from the green dot to the red dot? So again, we're just talking about distance. So let's count. Are you ready?
10, 20, 30, 40, 50, 60, 70, 80,
No, 75.
75. Now, remember, we basically said, okay, this is 50 yards and this is 25 yards. So if we're going to add those two together, it's just 50 plus 25. And we get 75. Now, here's the question.
I didn't get the fourth one.
Displacement. Displacement, if we look at our definition up here, is the distance from the starting point to the end point, no matter the path. So we're making like a beeline, like a straight line to it. So we're going from, come on, nope. We're going from here to here. That's how far we're going. That's displacement.
Oh.
That's
Green to
displacement. From green to red is displacement. So let's count. Here's our green dot. Let's count.
10, 20, 30.
Check again.
No, 25.
It's halfway in between 50 and 40, so let's do it again. 10,
10, 20,
25.
25. Okay, how far did the player travel from the green dot to the yellow dot? Let's count together.
10, 20, 30, 40, 50, 70.
60. From the yellow to the red. What is it? Come on, guys.
60.
Okay, no. Okay, it's 60 yards here. Okay, so let's count back from yellow to red. 10.
10, 20, 30,
Nope. 10, 20, 30.
40, 50, 60.
How far did the player travel from the green to the red dot in total? He traveled, watch my pointer, you guys. He goes from here. He travels how many yards this way? Yeah, you're right. And then he travels 100 or 60 yards this way. So how many total yards does he travel up and down the field? Say it. 60 plus 60 is 120. Yes, very good, Tyler. Now, displacement. The difference between the green dot and the red dot. Very good. It is 0. He started at the 20-yard line here, and he ended at the 20-yard line here. Does that make more sense now? All right, math problems. This will be your friend, I promise you. We are going to highlight I'm going to go through the same process. You highlight your variables. It will help you. Okay, you arrive in class at 45 seconds after leaving math, which is 90 meters away. How fast did you travel? What numbers do we have in there? We have 45 what? 45 seconds. Is that a measure of, what is that a measure of? Time. So we're going to highlight time in yellow. What's another number, Ashley? 90 meters. So is that distance or speed? Very good. And it says, how fast do we travel? So it's asking us, what is our speed? So if we're trying to find speed, we're going to cover up, you can't see my fingers, but we're going to cover up S. And what is our problem? Yep. Distance divided by speed. So our distance is what in this problem? What is our time? What's our answer? Very good. Okay, number 2. It takes Serena 0.25 hours to drive to school. Her route is 16 kilometers long. What is Serena's average speed on her drive to school? First of all, Tyler, what's a number that we have in there? Okay, is that time, distance, or speed? Huh? Time. Ooh, not what I wanted to do. Time. Christian, what's another number we have in there? Time, distance, or speed? Okay, and it says what is Serena's average speed, right? So what's our formula? What's our formula if we're trying to find speed? We cover up S and we get what? Divide what? We divide time over distance?
No.
No.
It's distance over time.
There you go.
Because of the other function.
Correct. So what's our distance here? What's our time?
Point.
I promise I will have a decimal on the test. At least in one problem. So, make sure that you don't say that's 25. Because I promise you that'll be one of the answers. Is that if you did that, it'll be... Of course. Of course. It is going to be on the computer, so you can use the computer calculator or you can use a regular calculator. So 16 divided by 0.25 is... Good job, Sue.
He's talking then.
He knows it. All right. Number 3, how much time will it take for a bug to travel 5 meters across the floor if it's traveling at 1 meter per second? Karina, what's a number in there?
5 meters.
Is that speed, distance, or time? It's distance. Very good. Amber, come on now. Okay. And Eileen, what's another number in that problem? Number 3. One, and it's 1 meter per second. Is that speed, time, or distance? No, it's meters per second. We have 2 units there, so that's going to be... Is it speed, time, or distance? Yeah, speed. So we're going to highlight it blue. Now, we have a little bit of different issue here, right? What are we trying to find?
The time.
Yeah, we're trying to find the time. So, if we're trying to find time, we're going to cover up time. So, what is our formula?
5 meters.
We divide distance and speed, right? Okay, so our distance is what? What's our speed? And we get 5 seconds. Number 4, how much or how far can you get from your little brother with a squirt gun filled with paint if you can travel at 3 meters per second and you have 15 seconds before he sees you? Jacob, what's the number in there?
3
3 what?
meters per second.
Is that time, speed, or distance?
B.
Very good. Keep doing that. Oh. Okay. Sue, what's another number in that problem? Number 4.
15.
Okay, 15 what?
Seconds.
Okay, is that time, speed, or distance?
Speed.
Just seconds?
Speed.
15 seconds is a measure of speed?
Yeah.
No. It's a measure of time. Seconds. Okay, and it says how far, so we are trying to find what number? What variable? Distance. So if we're trying to find distance, cover up D, and you multiply S times T. Our speed is 3 meters per second times 15 seconds. And we get what?
45.
We get 45 what? Meters?
Yes.
Very good. Okay, if you move 50 meters in 10 seconds, what is your speed? Our time is 10 seconds. Thank you, I had a brain fart there. Our distance is 50. And we're trying to find our speed, right? So, number 5, speed equals distance over time, which equals 50 over 10. We equal 5 meters per second. How'd you guys fare on those? Pretty good? Tyler, you did pretty good on those? Okay, good. All right. Now the graphs. How are we doing on time?
We have 10 minutes, thankfully.
Awesome. Okay, we're on our way. All right. Okay.
Are you gonna go any faster?
Take your time.
The video is going to be online for you guys, okay? So, what time did the bus leave school?
No, 9 o'clock.
9 o'clock. Right here. The bus left school at 9. What time did they stop for a picnic?
2 to 10.
Yeah, remember when you have that flat line? That's 0 distance. Okay, so they stopped for the picnic at 10. How far did they travel when they stopped for the picnic? Yeah, so they're traveling here to the picnic, and they have 50 miles. Very good. How long did they stop for? 30 minutes. If we go here and here, because at time 10 to 10:30, that's 30 minutes. What time did they arrive at the zoo? After they got done with their picnic, they got onto the bus, and they stopped at the zoo at 11:30. How far is the zoo from the school?
90 miles.
Good job. Okay, from here to here is 90 miles. All right. How fast did they travel in section A? So we start at 0. We're looking for our distance and we're looking for our time. What's our distance from here to here? 50 miles. How long? Not 10. 1 hour. From 9 to 10. It took them 1 hour, right? So they went 50 miles per hour. At section B, how fast did they go?
0.
0. It's flat line. How fast did they travel in section C? First of all, what is their distance here? They're going from 50 to 90. What's the difference there? No? 90 minus 50? 40. So we know our distance is 40, and how long did it take them? 10:30 to 11:30. That's how many hours? 10:30 to 11:30 is 1 hour.
1 hour.
So that's 40 miles per hour, right? Okay. Emma traveled to her grandmother's house and back. The distance graph shows information about her journey. What time did Emma begin her journey? 7:30. How far did she travel, or how far was she away from home at 8 o'clock?
23 miles.
Just 20.
It's 20.
Just 20.
So you don't want us to count like by 5?
0, 5, 10, 15, 20. The line crosses at 20.
Oh yeah.
How long did Emma stay at her grandmother's house?
2 hours and 30 minutes.
Okay, remember, if she's going zero distance, she made it to her grandma's house. So we know she got there at 8:30 and she left at 10. 8:30 to 9:30 is an hour, and then 30 more minutes makes 10, so it's an hour and a half. What time did she leave her grandma's house? 10 o'clock. Right here, she left at 10 o'clock. At 11:45, how far was she?
11:45.
Yep. So remember, this is the one you guys have trouble with all the time. Right here is 11:30, and right here is 11:45. So if we go up and see where it crosses that red line, and we go all the way over, we see it's halfway between 5 and 7, so that's 7.5. How far did she travel in total?
80?
Yes, ma'am. She traveled 40 miles here, and then she had to travel 40 miles back. Okay, how fast was she traveling at section A? Her distance was what?
40.
Her time?
30 minutes.
7:30 to
1 hour.
8:30. 7:30 to 8:30 is
1 hour.
1 hour. How fast was she going? 40 miles per hour. How fast was she traveling at section B? Yep, very good. It's a flat line. And how fast was she traveling at D? 30 to 0 is how many miles? 30 minus 0 is? How long did it take her to do that? 11 to noon. So what was her speed? 30 miles per hour. Okay, I know that was super quick, but I wanted to get that done before you guys left.